Hello. In our previous series of part 3 and 4, we had used TL494, a PWM IC. Block diagram of that IC. Internal structure, let's not go into more details about it because that will be very lengthy for explanation. We are seeing only the input and output. In the output, what we find, there are two transistors. One is complementary to the other, and their collector and emitter are open. Their collector and emitter are open for use. For this case. So what we do, we have to use a pull-up resistor at the collector here and here also, and the emitters are grounded. This goes high. That's how when the pulses come here, this goes high, this goes low, and this goes high, this goes low, as per the complementary concept. And most of the PWM ICs have the similar concept where we have some resistance and capacitance to be given for determining the frequency, and then the dead time control, which I discussed also. And there are some two error amplifiers which we will be using in subsequent series of this MOSFET drive, how to use them effectively for better circuit design. And then they have also a reference 5-volt reference out of the VCC supply, which is by and large the same, almost all, but then barring few, maybe having some few more features. But then this is another PWM regulating pulse width modulator, that is SG3524, which has got some better features. As usual, I told you about RT and CT, and there is a voltage reference. You get about 5 volt, which is to be used. And here, the same thing, collector is out, emitter is out, collector is out, emitter out. Same thing as we had seen in the previous one. But this has got some advantages, like it has got an error amplifier. Another error amplifier which is used for mostly current, for sensing the current and then trying to take action as per the design. Then it has also a shutdown feature. That means at any given time, a positive pulse can be given here, which will shut down the output, and in the process, everything will stop. So this is the difference between TL494 that we had seen previous and then the SG3524. But now let's see another one, which is SG3525. What is the advantage of this SG3525A? The advantage is it has a totem pole output. This kind of arrangement is called totem pole output, where they are internally connected to the supply and internally connected to the ground, but the combination or the joint pin of the emitter of this and collector of this is taken out. So unlike the other things where we had to use pull-up resistors, here you can also directly drive to the MOSFET. And the biggest advantage of the MOSFET drive here in this, that when it goes positive, but then when it goes negative, bypasses the capacitor, that takes out the charge from the MOSFET capacitor very effectively, so that this can be used for high frequency operations and better reliability. Apart from that, the same thing of course for the other output. Apart from that, the other things are almost same. There is a reference voltage available, and then synchronization also is available. Sometimes it is used. We will use them whenever it is required. That is, then oscillation also is available. Oscillation output, what frequency the oscillation is doing, and RPCT normally that's always there. And then there is a discharge also of oscillator for the discharging the oscillator, compensation. So many advantage pins we will all discuss when we start using this. And then there is a non-inverting inverting input for the error amplifier, and then the shutdown as usual. Regulating PWM IC, where it is very ideal for driving MOSFETs as compared to other ones which are not as efficient as this. Thank you.